obsidian. Prepare yourself for the man of black.
That money, Zelensky. NATO says you're good for it. Where's the money, Zelensky? Where's the money, Zelensky? Where's the fucking money, shithead?
Welcome back to CBS News 24/7. So we're seeing this video to our monitors. The U.S. Coast Guard is now federalizing this response to this oil spill off the Louisiana coastline. Officials say as much as 100,000 gallons of the stuff poured into the Gulf this week. The marshlands polluted, ecosystems exposed, dangerous toxins there in the water. So let's go over to CBS News reporter Katie Wise near the scene. Katie, you always bring these stories home from our local communities, especially the proud people of Louisiana. What's the impact there?
Well, good afternoon. It's been a very difficult week for first responders to get this spill contained. I'm told it's still very much an actively spraying spill from the leak site. In fact, it's been described like a geyser of oil shooting 30 to 40 feet up in the air out of the ocean into nearby wildlife and protected areas as well. And I'm told that it's taking an effort of more than 170 people to try to help contain this spill. Yesterday, I was able to speak with the captain from the Coast Guard. Let's take a listen to what he had to say about this response. What can you tell us about, potential reasons for this happening?
So it's hard to guess what the reason is, but we do know we are dealing with a well that was initially drilled back in 1942. So there's which has been there for a long time. So that is also part of the complications in planning for how we are going to actively secure the well. So it's understanding the integrity of the line and making sure that once we are there, we're ready to respond to anything that may come up that may cause us to change tactics.
Now, to put all of this in perspective for you, Reed, this all happens on the very same week that marks 15 years since the Deepwater Horizon oil rig explosion and subsequent historic oil spill that wreaked havoc across the Gulf states here back in 2010.
Wow, I didn't know that it was still ongoing, that it was actually actively spraying. That is so sad. Not just a spill, but a spray. Katie, thank you so much for that update.
I believe what began as an industrial accident hundreds of miles away could have such an impact on us. The crude crisis began on the evening of April 20th, 2010. It started as a fiery accident that led to the evacuation of 115 workers and the search for 11 others who were never found. But when the Deepwater Horizon rig collapsed into the Gulf on April 22nd, it ruptured a pipe, allowing oil to begin flowing into the Gulf. Efforts to activate the well's blowout preventer failed. Within a week, operations began to deploy tens of thousands of feet of boom to keep the oil from coming ashore. Other crews tried to skim up the oil or even burn it before it had a chance to reach the boom. On May 2nd, BP began drilling the first of 2 relief wells designed to intercept the well and then plug it permanently. 6 days later, the 90-ton containment dome designed to funnel the oil up to a pipe on the surface filled with ice and failed. So did another smaller dome called a top hat. This is the same day that tar balls started washing ashore on Dauphin Island. On May 10th, the government approved the use of dispersants to try to break up the oil. For weeks, it was tough to get a straight answer about how much oil was flowing into the Gulf. The estimate started growing, first 1,000 barrels a day, then 5,000 barrels a day, even though scientists insisted the amount was much higher. On May 20th, I talked to BP's Chief Operating Officer, Doug Suttles.
Our estimate's been pretty much consistent since the beginning, which is we think it's somewhere around 5,000 barrels a day, but I think we've always stated it's actually very uncertain.
A few days later, government scientists raised the daily estimate to 12,000, then 25,000, then as much as 60,000 barrels of oil. That's more than 2.5 million gallons of oil day after day, week after week. And that's the equivalent of the Alaskan Exxon Valdez disaster every 4 days. In late May, BP launched another attempt to stop the oil with the top kill operation to block the well with mud and debris. That failed. On June 4th, BP fit a containment cap over the well, enabling it to capture some of the oil escaping from the well. 10 days later, President Obama visited Theodore in Pensacola.
There's going to be a harmful effect on many local businesses, and it's going to be painful for a lot of folks. Folks are going to be frustrated, and some folks are going to be angry. But I promise you this, that things are going to return to normal.
July 12th, BP installed a new tighter fitting cap over the wellhead, raising hope that the flow of oil could be stopped from polluting the Gulf for the first time since the disaster began. And finally, on July 15th, oil stopped gushing into the Gulf for the first time since the leak began. And this afternoon, the Sierra Club says that civil lawsuits should result in penalties topping $60 billion, which it says better reflects the harm the BP inflicted on the Gulf.
And when I woke up this morning and I'm shaving and Malia knocks on my bathroom door and she peeks in her head and she says, did you plug the hole yet, Daddy?
Frustrated President Obama more than 5 weeks into the 2010 BP oil spill. It would take 7 more weeks to plug the hole, but restoration of the environment, 15 years later, it's not over yet. Mark Strassman has tonight's Eye on America.
Off Grand Isle, Louisiana, a sport fishing paradise, dolphins escorted us during our trip to the Gulf on Captain Craig Belkowitz's charter boat. He wanted to show us what matters here. The redfish are biting.
And if the fish weren't here, the dolphins wouldn't be here.
That's right.
Another sign that this place is recovered.
It's recovered.
Recovered slowly over 15 years. Grand Isle remembers the summer of 2010, the panic across the Gulf.
BP did this? They destroyed us.
Gushing like BP's ruptured well. A feeling of helplessness, frantic efforts to cap the well, bungled attempts to stop ribbons of rust-colored crude from poisoning beaches and wetlands. We covered BP's disastrous spill for 4 months.
All this oil, this is so heavy I can barely lift it, is part of a 16-mile slick.
134 million gallons gushed into the Gulf. Grand Isle became Grand Oil, stuck in the muck of disaster. Mayor David Camerdall fought tears.
I'm gonna lose this place when I know I'm trying my best.
We caught up with him again 15 years later on the same beach.
You were very emotional.
Seeing that all coming through, it was a whole different world for us.
Has Grand Isle recovered?
As the environment moved, it got better and better, we find, and the storms kind of came and pushed some big waves here and kind of pushed the other stuff out.
But below the surface, a different story. Back in 2015, Chris Hernandez showed us his oyster beds, covered in sheen.
Who's going to eat oyster that tastes like oil?
He told us recently those beds have never recovered.
No surprise, the spill had a devastating impact on marine life, coastal ecosystems, and wetlands. Over the last 15 years, some of it has recovered, and some of it hasn't.
Louisiana restored this bird island, home to brown pelicans, herons, and gulls. BP money paid for this $18 million project. Maurice Chantelier is the program's administrator.
We're into the restoration phase now, and we're trying to make right and bring those populations back.
But NOAA shot this underwater footage near the BP wellhead in 2017. Researchers saw almost no signs of life. They went back to the same area last year and say it looks much the same. 100 miles away, back on Grand Isle, Cammerdale still has his fears.
And I still think there's a little poison. I shouldn't say it that way, but it still could pop up in the ground.
Even 15 years later, you have that worry.
I do.
It took BP 4 months to seal the well, but there's still no cap on the lingering distrust. For Eye in America, Mark Strassman in Grand Isle, Louisiana.
An oil tanker ran aground today off the nation's northernmost ice-free port, Valdez, Alaska.
One of the worst oil spills in U.S. history brought Americans images of blackened beaches, dying wildlife, outrage, and betrayal.
The evidence is that the response was slow and inadequate.
Blame soon centered on the tanker captain.
It is now clear that the captain of the tanker, who was not on the bridge at the time of the accident, had been drinking.
But the accident also exposed the inattention to oil industry safety and led to promises to repair the damage that had been done.
We will consider whatever it takes to keep you whole.
And to do more to stop future spills.
We also rededicate ourselves to transportation safety and to realistic planning for accidents that do occur.
Nearly 25 years later, what happened to the promises made in the wake of the Exxon Valdez?
The Gulf spill might already be as much as 3 times worse than the Exxon Valdez disaster.
We've fetched up on the ground, evidently only get some oil.
Just past midnight on March 24th, the supertanker Exxon Valdez crashed into a reef off the coast of southern Alaska.
One of America's most magnificent waterways is blackened and befouled tonight by the biggest oil spill in American history.
240,000 barrels, 11 million gallons of Alaskan crude oil escaped from the huge vessel.
The oil industry's response plans had promised a swift cleanup in the event of a spill. But Ricky Ott was alarmed when she flew over the wreck.
We're 9 hours after the wreck, and there was not a speck of promised recovery equipment on the water. This had all been promised within 6 hours, and we were 3 hours past 6 hours, and nothing.
Neither Exxon nor Alyeska, the oil pipeline company in charge of the immediate response, was ready for such a large spill.
Alyeska was supposed to have an emergency response team at its terminal in Valdez, but 8 years ago the team was disbanded.
The response vessels were either under snow or being repaired. They were completely overwhelmed. Coast Guard didn't quite know what to do.
Equipment to fight this spill has to be flown in from as far away as Texas and England.
Exxon says it's using all available resources, but it argues the spill is simply too big to surround with booms and skim it up.
As images of the spill appeared on the evening news, Exxon began limited tests of chemical dispersants to try to break up the oil. The dispersants were controversial, and it was unclear if they would work or cause even more harm.
The chemicals that you use to cause the oil to sink is very dangerous to marine life, and we have to be certain that we cause a minimal amount of damage.
But it was soon too late to matter.
Winds up to 70 miles an hour virtually shut down the oil spill cleanup operation this morning.
The storm had come up and the oil was moving, and almost nothing could be done.
Some crews are literally on their knees using absorbent towels to remove the oil from rocky beaches.
Less than 15% of the oil was recovered. News cameras captured the damage.
800 miles of shoreline already covered with oil.
And the anger.
This should have been the easiest spill in the world to clean up.
Growing questions about how future disasters of this kind can be prevented, and why there was such a slow response to this spill.
At the same time, another storyline was also taking hold.
The Exxon spokesperson says there might have been a problem with Captain Hazelwood. It seems he had a bit of a drinking problem.
Good evening. The captain was drinking. The captain has been fired. That is the sum of it from Alaska tonight.
The story became Hazelwood.
top 10 excuses of the Exxon tanker captain. Number 10 was trying to scrape ice off reef for margarita.
That's a sensational kind of story. You have an immediate assignment of responsibility, an immediate villain. What was lost in all of that was the company's responsibility.
When a pipeline to bring oil from northern Alaska to Valdez was approved in 1973, the oil industry and the federal government promised to make safety a priority.
The Alaska pipeline's on its way. The environment will be saved.
The government initially supported double-hulled tankers and a high-tech navigation system in Valdez.
We were given blanket assurances about safety and spills. In retrospect, I erred in not making sure that what was said was not put in writing.
Those promises never materialized, and when the state of Alaska passed its own safety law, the oil industry sued, saying the law infringed on federal authority.
The court threw out the state's plan, so no double-hulled tankers, much more freedom to determine where the navigation channel would be.
When the pipeline first opened, tankers were closely monitored by the Coast Guard and stayed in the shipping lanes even when they were clogged with ice flows.
Instead of diverting out of the channel, they were supposed to slow down.
But by the time the Exxon Valdez left port, the Coast Guard routinely allowed ships to leave the channel to avoid the increasing amount of ice.
Slowing down was not something they want to do because time is money.
Judging by our radar, I will probably divert from the TSS and end up in the inbound lane if there's no conflicting traffic. Over.
A few minutes after that message, the Coast Guard wasn't monitoring the Valdez on its radar.
The Coast Guard is supposed to be the check in case the ship makes a mistake, and they weren't watching the ship.
Captain Hazelwood turned the bridge over to third mate Gregory Cousins and went to his quarters after giving instructions to maneuver around the ice.
Did you have any concerns about getting past the ice?
Not at that time, not at that instant, no.
Cousins continued going south, heading directly into Bly Reef.
A federal investigation later found that Cousins lost track of the ship's location and didn't turn back in time. It found that reduced tanker crews probably left Cousins overworked and tired, contributing to the accident, a conclusion Cousins and Exxon disputed. The investigation faulted Hazelwood for leaving the bridge and said his judgment was impaired by alcohol. Hazelwood denied he was drunk and was later acquitted of criminal charges related to drinking.
Did they have some fault? Yes. But the real fault was there wasn't the safety net.
Exxon spent more than $2 billion cleaning up the spill and says there was no long-term environmental damage. But pockets of oil remain beneath the surface of some beaches more than 2 decades later.
Prince William Sound is not the same as it was. The environment still has not fully recovered, and we're over 2 decades into this now.
Exxon paid $300 million to those hurt by the spill, and a jury later awarded another $5 billion in punitive damages. Exxon appealed, delaying the case for 14 years and leaving lasting bitterness in Alaska.
4,000 of the original plaintiffs have died since the Exxon Valdez.
In 2008, the Supreme Court cut punitive damages to 1/10 of the original amount.
The community is still very depressed.
Fishermen like Mike Weber say the local economy never recovered.
500 people left. That's a lot in a small community. I'll never recover from the oil spill.
After the spill, Exxon became an industry leader in safety, and millions of federal dollars were designated for cleanup research. Congress required better contingency planning, double-hull tankers, and tugboat escorts in Prince William Sound.
We were now making traffic out of Valdez probably the safest line of passage anywhere in the globe.
The explosion happened at the Deepwater Horizon rig Tuesday night.
Now everyone's hoping and praying that the Gulf of Mexico rig doesn't turn into an environmental disaster.
We're going to fight it subsea, on the surface, and on the shore.
After the BP oil spill, a presidential commission found that many lessons of the Exxon Valdez had been forgotten in the pursuit of offshore oil drilling.
I used the phrase that the offense got way ahead of the defense. The potential risks had increased dramatically, but there'd been no commensurate increase in our capability to avoid an accident or to respond to it.
It found that the major oil companies had made only a minimal investment in new response technology, and the government spent less than half the authorized amount on cleanup research.
The emphasis is always on preventing these things from occurring, because when they happen, we're not very well equipped to deal with them.
The news was again filled with the struggle to contain a massive spill, using much of the same crude cleanup technology used 20 years earlier.
We're still relying on booms, still relying on skimmers, still relying on shovels.
And response plans that were again unrealistic.
Lawmakers are alarmed that BP's competitors have given the government nearly identical emergency response plans. Those plans include steps to protect wildlife that does not even live in the Gulf.
And the government authorized BP to use nearly 2 million gallons of dispersants, though many of the same questions were still unanswered.
The key question that scientists are trying to figure out is whether oil dispersants in the deep ocean do more harm than good.
The commission also found that while tanker safety improved after Valdez, the oil industry resisted new offshore drilling safety rules.
It was reflective of a culture in the offshore oil industry. We ended up 20 years after Exxon Valdez with an even more serious incident, but no better prepared to avoid it or deal with it.
The other oil companies, including Exxon, have denied that a systemic problem exists.
We would not have drilled the well the way they did.
3 years after the spill, new commitments have once again been made to improve spill prevention and response.
3 years out from Exxon Valdez, there was still a deep commitment to applying the lessons that had been learned. 10 years out, that commitment had substantially eroded. If you come back in the year 2020 and ask, what have we learned? Are we safer? I think we'll know whether we really learned the lesson of Exxon Valdez.
Good afternoon. We begin with breaking news.
An explosion on an oil drilling platform
in the Gulf of Mexico.
On April 20th, 2010, an explosion occurred on the Deepwater Horizon oil platform.
The worst oil spill in U.S. history.
You could see that floating oil slick from space every day.
And what followed was millions of gallons of oil spilling uncontrollably into the ocean.
Well, it is almost unthinkable, isn't it?
This is a battle we're waging against an oil spill that is assaulting our shores and our citizens.
This video tells the story of the race to stop that spill. How engineers tried to plug a hole over 5,000 feet deep underwater. And I wanted to know just how much oil was actually lost in the disaster, and try different methods to better visualize the sheer amount of loss beyond just numbers alone. This is Deepwater Horizon Visualized. To visualize just how much oil was spilled, we first need some sort of measuring container. But ordinary containers won't do. So instead, we will be using the Empire State Building in New York City. Theoretically, it can hold up to 277 million gallons of oil. But to start off, our container is empty, as we look back to the evening of the disaster. On the evening of April 20th, 2010, everything still seems normal on Deepwater Horizon, with workers busy finishing up the borehole. What many may not know is that the Deepwater Horizon rig isn't actually an oil platform designed for extraction. Instead, it is a drilling rig used on new sites. Its job is to create the initial borehole and install a wellhead on the sea floor. And once that is done, it'll move on and another platform will take over for the actual extraction of oil. The The well itself is finished. The natural oil and gas reservoir has been reached. And all that's left to do now is create a seal so that Deepwater Horizon can finally leave, so that a smaller, less costly rig can take its place. For this transition, it is important that the well is completely closed off, and so the crew members are carrying out a test to make sure that the well is ready to be temporarily abandoned for the transition between rigs. But all of a sudden, the crew notices a huge spike in pressure readings. This is bad because it usually indicates that oil and gas has unexpectedly entered the well. The crew then runs the same pressure test again, but it is the same result. This is especially bad news for oil giant BP, considering it cost them more than $1 million a day to operate the rig. And at this point, Deepwater Horizon is already more than 6 weeks behind schedule to move to its next location. Economic pressures that may have resulted in a culture of negligence. Despite the alarming pressure readings, the crew decides to carry on. And then, just before 10 p.m., those still awake on board of Deepwater Horizon are shocked when a geyser of mud and seawater begins gushing out of the well and showering the rig. Before anyone can grasp what is even happening, the worst-case scenario occurs. Oil and gas escapes from the wellhead and rushes up to the platform, where the gas explodes.
We're looking at new pictures from the scene. The Coast Guard says the explosion happened around 10 o'clock last night.
There's a desperate search in the Gulf of Mexico
For 11 people who were on a drilling platform when it exploded.
Of the 126 personnel initially on board of Deepwater Horizon, 115 are rescued, but 11 men are missing.
The rig is still burning out of control.
We have covered approximately 1,940 square miles of search area.
A desperate search is carried out for the missing men. But as the evening rolls over into the next day and the sun begins to rise, it isn't looking good. By day 3 of scouring the Gulf and still no sign of them, the search is called off. Tragically, all 11 men were presumed to be near the blast and were unable to escape in time. The fate of Deepwater Horizon is looking just as grim. Emergency responders attempt to put out the blaze, but this is made complicated by its remote location in the Gulf of Mexico, as well as oil from the well continually fueling the fire.
It was, you cannot imagine how enormous this rig is anyway. It's the size of 2 or 3 football fields.
There is little anyone can realistically do, and any attempt to douse the enormous fire is in vain. And while creaking and groaning, the rig finally begins to tilt into the Gulf. After 2 days of burning, it only takes minutes for Deepwater Horizon to slip beneath the water's surface and sink to the bottom of the sea. The fires come to an end, and yet it doesn't mark the end of the disaster. In fact, this was still just the beginning, because deep down below, the well Deepwater Horizon had drilled is now leaking into the Gulf, starting to fill our measuring container with oil. Initially, BP reported that no oil was escaping into the sea, but this was corrected just a few days later when a new report came out that there was indeed a leak. As the extent of the spill became more apparent, BP began feeling the immense pressure to close the leak as soon as possible, and our first order of business is to send a remote-operated vehicle down to the well itself. This vehicle should provide answers and help them figure out where exactly the oil is leaking from. Every well drilled has a very large complex structure installed on the sea floor called a blowout preventer, or BOP for short. The drill pipe from the rig to the well must run through the BOP, which is a safeguard to prevent uncontrolled oil and gas from traveling up the drill pipe and to the rig. Essentially, the BOP is there to prevent exactly what happened here, a blowout. To do so, the BOP has two systems that can be used to close a well. Pipe rams, which are heavy metal blocks that can clamp together to stop the flow, and annular preventers that close the pipe using a rubber seal. And on the day of the accident, crew members on the Deepwater Horizon platform did actually deploy both systems within the BOP in an effort to close the well. However, because these systems were activated too late, they didn't work as intended. Oil and gas had already entered the pipe above the BOP, meaning there was nothing left to stop it from reaching the rig. In theory, this also should have been preventable, as there was one final failsafe within the BOP that should have been engaged to close the well: the blind shear ram. Once activated, the blind shear ram uses a sharp metal blade to cut the pipe and form a seal. Crew members later reported that they tried to activate the blind shear ram after the explosions, but because they had lost power, the switch didn't work. However, this also shouldn't have mattered, as the BOP is designed with a fail-safe mechanism to automatically engage the blind shear ram if it loses connection with the rig, such as in the case of a power outage. Why this didn't work is a mystery to the experts, and something the ROV will study. And once they are able to reach the BOP, a devastating sight is waiting for them. The crew sees that the blind shear ram did engage, but because the pipe had buckled, it did not cut the pipe as it should have. Rather, the ram punctured the pipe, thereby making things even worse and allowing a large volume of oil and gas to escape. Now aware of the full extent of the problem, it was time to come up with a plan. The only guaranteed way to permanently seal the well will be by drilling a completely new borehole that intersects with the existing one. That way, mud and cement can be pumped through the new entrance to seal the leak, eventually choking the flow of oil and gas completely. The crew begins drilling this relief well 12 days after the explosion, and a week later they begin drilling a second one, just in case the first should fail. But this process will take months, and every day until then, the well will still be leaking, causing massive environmental damage, and filling up our container of the Empire State Building. Therefore, experts head to the drawing board to figure out alternative solutions that could lead to a faster result. And they come up with an idea. What if they could simply cover the leak with some sort of dome? A structure like that exists, and it is called the cofferdam, a large steel and concrete structure weighing nearly 100 metric tons. A solution that has never been tried before this deep. The cofferdam is designed with an opening on the side so that it can be lifted over the broken pipe, and on the walls of the cofferdam there are 4 flaps. These are there in case the dam starts sinking into the ocean mud, to prevent it from sinking too low. If everything goes to plan, most of the oil would rush up and flow through a pipe inserted into a smaller opening at the top of the dome, and from there the oil would be directed up to a tanker ship. To turn this plan into reality, crew members are slowly getting to work lowering the cofferdam into the Gulf. But almost immediately, there is a problem. As the cofferdam descends into the colder, high-pressure depths, the gas escaping from the well reacts with the surrounding water and forms methane hydrates, essentially ice crystals that block the opening at the top of the dome. And with the opening frozen off, the oil and gas inside the dome now has nowhere to escape, and therefore the entire cofferdam becomes dangerously buoyant. Almost like a balloon, the oil fills the cofferdam and makes it rush up back towards the surface. The crew members above are now staring down a potential disaster, because as the cofferdam begins rushing up, it is heading straight towards one of the response vessels above. Thankfully, the crew is able to get it back under control, with enough time to direct the cofferdam away from the vessel. Nonetheless, they have to abandon the dam, which eventually sinks back down to the bottom of the ocean, where it will remain abandoned. With this attempt a bust, there's still no time for frustration, and the engineers immediately jump back to the drawing board. They come up with Plan C, the pipe. For this to work, they will attempt to siphon the oil and gas to a tanker, but this time without a cofferdam. Rather, they simply insert a smaller pipe into the broken well pipe. And this method actually works to a degree. The crew is able to start collecting some of the oil in a tank and flare the natural gas overboard by diverting it away from the ship and setting it ablaze. The oil flow is finally slowed down. Our measuring container is filling up slower now, but it is still steadily increasing as oil leaks out around the pipe. And so, experts move on yet again with their next idea. And they come up with their plan for the so-called junk shot. To do this, a very complex procedure is set up underwater near the well. And a new drilling vessel, the Q4000, is positioned above the leak site. Using this vessel's pipe, heavy drilling mud will be pumped into the BOP, along with lots of different junk. This includes anything from golf balls to rubber tires or knotted rope. The idea is to use the weight of the mud and junk to force the oil back down into the well, so that in a second step, cement can be poured on top in order to create a seal.
It's kind of like stopping up a toilet, plug up the blowout preventer, and then at that point, once we get it plugged up, we can actually pump heavy fluids down the well and hopefully stop it from flowing and then pump cement after that.
With fingers crossed, crew members start the process. Mud and junk are shot into the damaged well, and using underwater cameras, crew members monitor the situation. But yet again, nothing goes to plan, as they watch the junk get spewed right back out. The pressure from the well is simply too high, meaning any material dumped on top is simply displaced by the gushing oil. The crew attempts the junk shot several more times, but it is a futile effort. And experts warn that if they continue trying, it could lead to instability in the well, causing what's known as an underwater blowout. This would mean that oil may begin escaping not just from the well, but also from many points throughout the surrounding seafloor. If this happens, containment will be virtually impossible, and so they abandon the junk shot idea. And suddenly, it's back to square one yet again.
Cleanup is costing $6 million a day, and when it's all over, the price will be over $1 billion.
With the initial boreholes from Plan A still far from reaching their destination, the engineers decide to revisit the idea of a containment dome. Even though it didn't work with the original large cofferdam, this time they decide to go for a much smaller, better-fitting cap that could be installed directly onto the BOP. Rather than encasing the entire area with a large dome, they could direct the oil flow straight through this cap. But there is one issue. In order to do this, they will need to cut the damaged pipe that is still connected to the BOP. Up until this point, the kinks in the pipe have been helping to actually slow the rate of oil that is leaking out. And if it is cut off, the rate of oil escaping will likely increase by as much as 20%. It is an extremely risky move. If this cap doesn't work, then they will have made the situation worse for nothing, but they have to try. The decision is made to cut the damaged pipe off from the BOP. Oil starts rushing out at a faster pace than ever before, and the clock is ticking. It takes several days to situate the new smaller cap on top of the BOP. Having learned from the freezing issues with the previous cofferdam, this time warm water is pumped down to hopefully prevent the formation of ice crystals. And as engineers watch the underwater vehicles at work, everyone holds their breath. And then, with the cap in place, the oil starts to flow, and everyone sighs with relief as it actually works. The cap has created a seal and is collecting a large portion of the oil, sending it up to a collection ship on the surface. In fact, so much oil and gas are collected that several more vessels are added for storage and processing. But the work still isn't done. Even though this is the most progress experts have made in stemming the flow, they still aren't capturing all of the leak. And our container continues to fill, though at a slower rate. Throughout the next month, engineers are able to devise and install a series of better fitting caps, each one lowering the amount of oil escaping into the sea.
The story today is that they're going to literally put a new cap, a new top, that may not be the right nomenclature, on the well that's been leaking in the Gulf of Mexico for up to weeks and months or whatever.
Until finally, a tight enough cap is installed that is able to completely stop the oil from leaking for the first time in 3 months. 86 days after the initial explosion, the oil finally stops leaking into the ocean. However, tensions are still high, as there is no telling how long the temporary capping can hold for. Luckily though, it does hold for the time it is needed. And eventually, the first relief well reaches its destination, intersecting with the original well. Almost immediately, heavy mud and cement are now poured into the bottom of the well, and the news is delivered to the world that the well has officially been successfully and permanently sealed. 110 days after the whole ordeal began. In the end, approximately 134 million gallons of oil were lost in the Gulf of Mexico, filling our container to about 50%. And this is the figure prominently cited across a bunch of articles. And yet, this figure is only a conservative estimate of how much oil was truly spilled. A group of independent scientists and researchers came together with their own assessment, and they measured the flow of oil as seen from videos of the leak and calculated effects from pressure, temperature, geological conditions, and many other factors. And according to their estimate, over 210 million gallons of oil were actually lost in the leak. A massive increase from the official calculation, now filling our container up to about 75%. And this is just the pure crude oil, though it is important to remember that every gallon of oil can coat huge areas of sea surface, as visible by this satellite image taken by NASA, showing the oil-covered sea in the Gulf of Mexico.
We found that the animals that lived in the nearshore environment had lower survival rates. We saw 900 plus dolphins strand or wash ashore, many of them dead.
BP has heavily contested this larger figure, claiming that it doesn't take into account the hundreds of thousands of gallons that were siphoned and collected before it could enter the Gulf's waters. Though it is also important to note that BP has a vested interest in keeping the figure as low as possible. In the end, it is impossible to know the true exact amount of how much oil was lost, but what we do know is that no matter which of the two figures you go with, Deepwater Horizon was the world's largest accidental spill to date, with irreparable damage done to the ecosystem and the loss of life of 11 men who were working on the platform when it exploded. Plugging a hole over 5,000 feet below the ocean was a massive challenge, but it's the kind of high-stakes problem only the best engineers can solve. And for my next video, I focused on a completely different kind of engineering marvel, one that happens much closer to the surface, on a racetrack. As for my upcoming video, I have animated an entire Formula 1 pit stop in order to understand how it's possible to change all 4 tires of a race car in just 2.5 seconds. This video won't be on YouTube for another month, but you can already watch it right now if you have Nebula. On Nebula, I not only post all my videos early, but I also post exclusive documentaries that are not available on YouTube. For example, I have made a full-length video about the fascinating construction of the Twin Towers, explaining the groundbreaking new methods used to build these iconic skyscrapers. The video is part of my Nebula original series Underexposure, in which I explore often overlooked aspects of topics we all know about. I've made a video about the investigation into Flight MH17, or a video about the Bin Laden raid, and lots of other topics. The idea behind Nebula is pretty simple. It is a platform that I am building along a bunch of other creators. And since it's a subscription service, we can use that revenue to create larger, higher budget projects.
I get to sleep out in the snow tonight.
Yeah, bring it on!
There's no script for this.
We have a ton of exclusive documentaries, and we also have creator-run game shows, comedy specials, and even feature films. So go to nebula.tv/neo, and if you use exactly this link, you will actually get a 40% discount of the annual plan. That comes down to just $3 a month to access all of Nebula, where you can watch all my exclusive videos. So thanks for your support, and thank you so much for watching.
That massive oil slick now covering some 600 square miles of the Gulf of Mexico, and it could start reaching the United States coast within hours.
Coated in crude, tonight the waters and beaches of Southern California show the stains of a slow-motion disaster. State records now indicate the first reports of the massive oil spill came in the day before officials confirmed it. The size also larger than initially reported, up to 144,000 gallons of crude, and now potential evidence of an anchor strike. Contracted divers discovering a 4,000-foot section of the nearly 18-mile pipeline was displaced by over 100 feet, a 13-inch split cracking open the pipe, spewing oil.
The pipeline has essentially been pulled like a bowstring.
From just over the spill site, we saw how difficult the cleanup has become.
Evidence from the spill stretches from the beaches of Orange County all the way to Mexico, but crews are having a difficult time tracking the ribbons of oil because they've been dispersed after a thunderstorm here.
Today, a flotilla of boats are corralling the oil they can, but so far, just 3% of the spill has been recovered. patties of tar are still washing ashore. The true ecological damage and the deadly impact to wildlife and the food chain may not be known for months.
A lot of people think, well, some fish and some birds, but it's far more extensive than that. This is very serious. It's catastrophic.
With the lawsuit just filed and likely facing millions of dollars in fines, the oil platform operator has still not confirmed if its leak detection system went off.
With just over 20 offshore rigs dotting the coastline, many say a disaster of this scale was inevitable. Now there's renewed calls to shut down offshore drilling.
We've had the entire Orange County coastline potentially fouled by oil. If that is not a call to action for us to stop this practice, I don't know what would be.
Tonight, a push for change and the race to slow this seemingly unstoppable disaster.
Looks like tedious work there, Miguel. And I know a lot of discussion today on when this oil leak was first reported. It's really about the response.
That's right, Lester. We know the initial report happened on Friday, but the Coast Guard couldn't find the leak until Saturday. So for 18 hours, tens of thousands of gallons of fuel poured right into the Pacific Ocean.
Thanks for watching our YouTube channel. Follow today's top stories and breaking news by downloading the NBC News app.
All right. Welcome back, everyone. Here to live now from Fox. I'm your host, Mike Page. We come on with some breaking news that we want to bring to you. Massive developments coming out of North Dakota, where officials have shut down the Keystone Oil Pipeline in North Dakota after a rupture has led to the release of oil. So with the very latest here that we are getting from our partners and team members, the Keystone Oil Pipeline ruptured this morning in North Dakota with the spill confined to an agricultural field. An employee working at the site near Fort Ransom heard a mechanical bang and shut down the pipeline with about 2 minutes. Spill investigation programs are underway right now and trying to look at what caused this rupture. Oil was reported surfacing about 300 yards south of the pump station in a field. Emergency personnel responded to the site. The cause of the rupture and the volume of crude oil spilled are not immediately clear at this moment. Of course, the Keystone Pipeline has been operating since 2010, sending oil from Canada to parts of the U.S., including Illinois, Texas, and Oklahoma. So again, we'll be keeping an eye on this story for you right here on Live Now from Fox.
Did you know there are thousands of abandoned oil rigs in the Gulf of Mexico? Most people have no idea, but literally thousands of oil platforms have been left to rust in the ocean. Most oil companies don't even bother dismantling the rigs once they're done. Instead, they use legal tricks to avoid responsibility. One common tactic is to transfer ownership of an oil rig to another company right before it stops producing. That way, the original company doesn't have to deal with shutting it down and dismantling it properly. Many of these rigs are also labeled as temporarily abandoned, even though they're clearly left for good. Removing all these abandoned rigs would cost tens of billions of dollars, and if the companies won't pay for it, taxpayers will likely end up covering the cost eventually. It's a massive issue that hardly anyone talks about. Meanwhile, these decaying rigs are poisoning the ocean, and it only gets worse as more oil rigs continue to be abandoned.
This machine weaves human hair to make mats. And this nonprofit has been using them for decades to help clean up oil spills.
I'm going to show how fast it soaks up the oil, how clear water pours off of it, and the hair holds the oil.
1 kilogram of hair can soak up around 5 times its weight in oil.
I'm just trying to get every nook and cranny here. I mean, this is literally just the hair from your head.
But for most cleanups, oil companies use mats made from petroleum or spray chemicals that can make people sick. So if this method works, why aren't more oil companies using it to clean up their messes?
Maybe the weirdness makes it, just more interesting. I don't know.
We went to San Francisco to see how hair mats can clean up worldwide waste. Matter of Trust has been making hair mats since the year 2000. Founder Lisa Gauthier sources hair from salons in over 30 countries.
We have what we call the hair force.
The donated clippings arrive in small batches.
People mail this in every day. We get, I don't know, roughly 10 or so envelopes a day. We get a lot of blondes. As you can always tell when we get a package from Los Angeles, like right away, blonde, blonde, blonde. A lot of redheads in Boston. This is probably from Boston. We've been told that we got a package of underarm hair from Michael Phelps and the Olympic swimming team.
The team also uses animal fur.
Clippings from alpaca, buffalo, sheep, etc., llamas.
Lisa and her team of felters start by cleaning the bags of donations. A lot of these were swept off the floors of hair salons.
Pins, cigarettes, food, anything sharp, anything hard that might break the needles, all of that is garbage. I don't find it gross at all. I have a lot of hair and it doesn't bother me. It's part of the charm of it.
The felters lay out the human hair on this bed of dull nails and start to layer it with animal fur and fleece.
We had to learn that we needed to not use sharp nails because it would start to slice the hair. And David invented this for us, and he created it so that this thing just lifts up and it's really easy for us to remove it afterwards.
We get out and make it more neat and faster.
Then these machines tighten the fibers. The final product looks and feels like a doormat.
Feel how sturdy that is. It's really sturdy.
The idea to use hair to clean oil spills started in 1989 with Phil McCrory, a hairstylist from Alabama.
He was watching the Exxon Valdez oil spill in William Sound, Alaska, and on CNN it was showing the otters covered in oil and the water around them a little bit cleaner.
Phil looked down at the oily head of hair he was shampooing.
And it just sort of snapped for him. You shampoo because hair collects oil. I cut, a pound of hair every couple of days. All of this could be going to clean up oil spills.
So 10 years after Phil came up with the idea, Lisa partnered with him to scale up. At first, they stuffed nylon stockings with hair to make booms shaped like sausage.
We're going to stop doing as many booms as we have because they needed the nylons, which was again plastic, to hold them together. And we're going to start doing more mats because mats add surface area. And so it just collects even more oil.
That idea was put to the test in 2010, during the largest oil spill in American history. BP's Deepwater Horizon spewed 4 million barrels of oil into the Gulf of Mexico over 3 months. And Lisa's team got a flood of donations.
We just started to get in ponytails from people just, cutting it off. And then, of course, it was spring and it was shearing season. And turns out there's buffalo herds in the United States. So there was a lot of fleece just coming at us in trucks and mail trucks and everything. It was fantastic and overwhelming. We had 19 warehouses, about 100,000 square feet each from the Florida Keys all the way to Texas, right on the water because people are just so generous.
Lisa says that a representative from BP reached out to her about a partnership. Insider asked BP about that, but the company didn't get back to us. In the end, the oil giant didn't deploy her hair booms. NOAA, a governmental organization, helped run the cleanup effort. Scientists concluded that hair booms weren't as effective at removing oil as booms made with polypropylene, an oil derivative.
The booms would get water oil, they would get saturated in water, become heavier than the water and start to sink in the water. And then whatever oil they had on it sunk with it, and recovery was very, very difficult trying to get those back out of the environment. You don't see that with the poly booms. These polys do not absorb water like our hair does.
BP instead tried to burn the oil off, but the fires only covered a small percentage of the spill. The company also sprayed dispersants to dissolve the oil and push it toward the ocean floor, where much of it remains today. And those chemicals can make people sick. But the consensus was that the oil was less harmful at the bottom of the ocean than washed up on shorelines.
It's a trade-off. Sometimes they use the word net environmental benefit, but it's not net plus, it's net less bad.
Still, locals along the coast used Lisa's hair mats to protect their beaches.
The EPA told us that our BP response was the largest grassroots mobilization they had ever seen. And I was out there in Mississippi, Alabama, Louisiana, Texas, and Florida.
Eventually, BP was able to plug the leak on its own. But Matter of Trust proved it could mobilize thousands of people to address an epic catastrophe. The number of large oil spills has gone down in recent years, but Matter of Trust is now focused on a much more common problem: motor oil that drips from cars on the road and makes its way to the ocean.
There's many ways that oil gets spilled, and the way that we concentrate on is oil that contaminates our waterways is actually just drips on the street, mixing with rainwater and getting into storm drains.
And those drips add up to over 180 million gallons per year. That's 16 times the amount spilled by the Exxon Valdez. Another use for the hair mats? The US Air Force is experimenting with them to manage chemical waste on its bases.
They're doing a very large system with contaminated water reservoirs.
And once the mats have done their job soaking up oil, how does Matter of Trust plan to get rid of them?
It actually can break down into compost. It takes a really long time, and it's not our number one idea for the circular economy. What we think is better is if we have really clean incineration.
Even as she grows her business, Lisa wants to make sure her hair mat process remains an open source technology.
Phil McCrory had a patent which expired, and we all decided that it's everybody's hair, and we're a public charity, and we thought that it was best not to renew it, and we just thought it's something that should be offered to the world.
She's shipped her machines to more than a dozen partners around the world.
We just had a really great meeting, a big Zoom meeting with all of our partners around the world, and everybody was super jazzed, because I think we're just getting into that next level now where we're looking at how to send out more and more machines. And we have one in London, one in Wales, France, Switzerland, Finland, Athens, Greece, Tokyo, Santiago, Chile.
And she says it's possible to do this work from home.
For us, cottage industry is the future. Anybody can make a little felted experiment just by putting a bunch of hair and fur in your shoe and walking around in it for a while. The heat from your heels and the sweat and the jostling from your shoe, you pull it out and you will get a little mat.
And you've tried this?
Oh yeah.
This oil painting is worth a lot of money, because it's actually a gigantic oil spill. Gross. But not to worry, it can still be picked up and salvaged with a special kind of sponge. No, not that sponge. No matter what your take on fossil fuels or renewable energy is, I think we can all agree that oil spills are not great. And we need a better way to clean them up. Right now, we mainly just set them on fire. Yeah, just burning the ocean.
It's called an in situ burn. You get it so it's thick enough on top of the water that you can strike a flame and it'll actually just burn away.
But what if you could pull that oil out and use it? And what if we all might be sitting on the solution?
The starting material, I'm actually probably sitting on right now. It's polyurethane foam.
It turns out this super common material with a few atomic modifications can clean up oil spills better than anything else we've got. Which is good, because we spill a lot of oil. A few 100 million gallons every year.
The big ones happen once in a while and they make front page news. But there are actually thousands of oil spills every year just in the United States.
A new wave of material sciences could help us start cleaning the environment instead of just, using it as a trash can. This is Hard Reset, a series about rebuilding our world from scratch. Everyone, hold on to your butts. Hey, it looks like someone was filming while I was monologuing. That's me. So just like the United States has a network of national parks, it also has a network of national laboratories where incredibly advanced research can be done that isn't quite feasible for industry to carry out. The most famous national laboratory, Hawkins National Laboratory, where they help orphans find their true talents, apparently isn't even real. I know, I'm disappointed too. It was probably loosely based on this place, Argonne National Laboratory, which was built in the woods, totally normal, and has these very not weird buildings that are definitely not housing gates to other dimensions or demogorgons.
Science builds on itself. You're always standing on the shoulders of giants, but a stack of giants.
This is Seth Darling. Seth helped create a new oil-loving sponge from an everyday material.
Everybody interacts with polyurethane foam all the time. It's used in furniture cushions, insulation, and other things. Super cheap, made on a huge scale. It would be great if you could just take polyurethane foam and have it soak up oil. But unfortunately, polyurethane doesn't like oil more than water. In fact, it likes them almost exactly the same.
But what if you could change the surface properties of polyurethane by applying a super thin layer of some other material, like 4 billionths of an inch thin? Jeff knows all about that.
The research that I do is ways to put down single atomic layers that can make a profound impact on society. And in this case, it's the ability to clean oil from seawater. The particular technology that we do, this atomic layer deposition, is able to put single atomic layers on the outside surfaces of materials and change their functionality. That's what we did for Oleo Sponge.
The idea is that if you can lay down a single layer of atoms or molecules, you can totally change how an object interacts with the world around it. For example, you can make something hydrophobic, so water rolls right off of it. Or you can make it oleophilic, so oils cling to it.
So we start with polyurethane foam, and then we do a 2-step process to it to change its surface chemistry.
First, they coat the entire interior surface of the foam with molecules that have aluminum or zinc in them. This makes it easier for another layer of molecules to be applied on top. The second step is to apply that layer of molecules, called a silane.
That one end of the silane molecule binds very strongly to those metals. The other end of the silane molecule was chosen to love oil.
Let's go to the next lab.
So how do you add these teeny tiny layers? Well, in this teeny tiny reactor. It's real small, like a pipe. It's a pipe.
So let's open the reactor. So now we'll load bunch of polyurethane foam. This is very quick, just 10-minute job to coat 1 nanometer.
Inside this pipe, reactor, the temperature and pressure are controlled with incredible precision while the chemical vapor is inserted.
So now when we take that sponge and we put it down into oil and water, it doesn't grab any water because it's hydrophobic, but it grabs oil voraciously. That's why we call it oleophilic, oil-loving.
Yeah.
It loves the oil.
And once you've got an oil-loving sponge, you can get started cleaning up the world, right? Well, almost.
We've had a lot of interest from companies asking us, this sounds great, can you send us 50 square meters? And we say, sorry, we can't do that right now. We can send you a 1-inch cube, or if you give us time, we'll send you a lot of 1-inch cubes. But that's the bottleneck, is the scale up of the manufacturing.
Sounds like you need a bigger pipe.
Yeah.
Remember in Superman 3 when Superman literally blew oil right back into a tanker? Neither do I. But it might actually not have been the most unrealistic thing about this movie.
The mindset with oil spills today is let's just try and get it out of the environment. And it's sort of already assumed to be a loss. Oleo sponge is a hard reset for oil spill cleanup. It's a lot more sustainable and makes a lot more sense than burning oil, which is the dominant technique that's used today.
Other ways of cleaning up oil from the ocean will put that problem somewhere else. They'll either convert it into CO2 so that it causes global warming, or they'll end up stuffing a landfill.
But just like Superman, Oleo sponge has the potential to grab all that oil and put it right back into a tanker. It just needs to scale up a bit.
There's a big gap between a 1-inch cube and addressing a spill in the open ocean. So we've taken some steps towards scaling it up. There's a big facility in New Jersey called OMSET. It's a gigantic tank so they can actually spill oil into seawater, but not in the open ocean, and train people on how to clean it up. And it's also used to test new oil spill technologies like Oleo sponge.
The Oleo sponge team made 10,000 little cubes and sewed them together. And with these, they were able to test this technology on a large scale. Most oil removal technology is limited to the surface, but Oleo sponge can be dragged under the water to clean up below the surface.
That was actually our main goal in developing Oleo sponge. It works great on slicks on the surface, and we hope it'll be used for that. But we really wanted to solve this challenge for which there is no solution today, oil in the water column. We weren't sure it would work, but it actually did amazingly well. It was the first successful demonstration of pulling oil out of the water column like that. When they did the chemical analysis, it worked with different crude oils and even with diesel fuel, which also gets spilled into water a lot. That's a refined oil product.
The oleosponge pulls oil out of the water, but it can also be wrung out again and again and again. The other big difference is that the recovered oil can actually be used instead of just, burning it.
You recover the oil, you reuse the sorbent. It's just a completely different way of attacking an oil spill.
So picture a scenario where a ship drags a net of these sponges behind it, wringing out the sponges and recirculating them as it goes. A single boat like this could pull tons and tons of oil out of the ocean. That oil wouldn't be a waste product, it would be a usable commodity. You could sell it and refine it into all the wonderful things we typically pollute our environment with, like plastic and gasoline. But this isn't just a hard reset for cleaning up oil spills. It could also have huge implications for every aspect of how humans use water.
Using our innovation in material science and materials chemistry to tackle water challenges is really a revolution in how we think about water, which is to close the loop. Instead of going once through, you take water out of the environment, you clean it if you need to, you use it, but now instead of dumping it back into nature again, you clean it up enough and reuse it.
If we could clean up our wastewater to the point where we didn't need to take as much out of the environment to survive, we wouldn't need to deplete the groundwater that has taken tens of thousands of years to accumulate, or take water out of the rivers and lakes that have replenished those sources. But first, we need this technology to be widely available.
We need somebody to take this technology, make the tools that someone can then buy to manufacture it, to sell to all of these people who are lined up down the block ready to buy it.
You can't help but think, gosh, if only there was some giant industry with lots of money and power and a global logistics network that might contribute to oil spills in some way. Oh well, seems unlikely. But then again, it also seemed unlikely that Superman 3 would be an accurate prediction of the future. Come back next time for another episode of Hard Reset. Subscribe to Freethink to watch our other original series and documentaries about technology and people that are changing our world.
I'm Doug Stanhope, and that's why I drink.
Your hatred of American culture culminated with you spilling billions of barrels of oil into the Gulf of Mexico. And I understand, yes, you don't like America and we don't have a worldview and we think everything revolves around us. But it was a shitty thing to do. The entire summer was BP oil.
81 days in, with BP still using dispersants, the first glimmer of the price that will be paid.
Another day of the BP oil spill. Round-the-clock coverage of oil leaking. We have cameras on the oil spill, and now let's look at a close-up of the camera of the BP oil spill. Everybody's angry about the oil spill.
Man, you got to get down here and take control of this, put somebody in charge of this thing and get this thing moving. We're about to die down here.
They have coverage of boycotts, people protesting BP gas stations. Well, you're irresponsible.
BP's oil spill's got to go. Hey, hey.
You fucking drove to that boycott with a car. Unless you're boycotting petroleum, you're doing nothing. I have a list of things that I'm concerned with, and the oil spill is not going to make the list. There's a lot of other problems in the world. Maybe someone, Kevin Costner, is concerned about the oil spill. He built a machine.
The news picked up on this stupid story and ran with it.
Meanwhile, the cleanup effort along the Gulf Coast, that is getting some star power. It is called the Kevin Costner Solution.
Every day was just unending coverage.
Those with a science background will find our machines easy to understand. They are designed to separate oil and water.
Don't they do that by themselves? I'm going to build a machine that makes cats hate dogs. Dawn dish soap exploited this to a level that I found obscene. Dawn dish soap, just some dish liquid, had a commercial where they came out showing ducks or waterfowl of some kind coated in crude oil.
Not today, 'cause they're gonna wash away.
And if you see the commercial, you see a duck covered in oil. Unless you're a complete sociopath, you're probably pro-duck. You're rooting for the duck. But you think the commercial, it's an environmental concern. SaveADuck.com. Throw us $1. No, it's for Dawn dish soap. We get your silverware sparkly clean, and then we save a duck in our off hours. How obscene, how vulgar is that to exploit a tragedy of this level just to promote some dollar store dish soap? Is that not exactly the same as using a rape victim to promote a feminine hygiene wash?
They're gonna wash away this all, I'm gonna take them away. I got troubles though, but not today. 'Cause they're gonna wash away. They're gonna wash away. They're gonna wash away this all, I'm gonna take them away.
Who's that? Who is it? One of his pair of clothes? Why aren't you rolling?
It's him. It is him. You guys are in so much trouble.
You know, I thought you were stupid, friend. But I underestimated you. You were a total freaking retard.
I want the girl. That's all.
Well, what on this screwed up earth makes you think that you're gonna get her?
You know what this is? I drop it, you burn. We all burn.
Let's not do anything rash here. I mean, you sure she's worth all this? I mean, she never does stop talking. She never shuts up.
I noticed.
What is it then, huh? It's the map.
She's my friend.
Golly gee, a single tear rolls down my cheek. You're gonna die for your friend.
If it comes to that.
He's bluffing!
Bluffing? He never bluffs.
Shut up! I don't think you're gonna drop that torch, my friend.
Why not?
Because you're not brave.
Oh, thank God.
Mr. Obsidian, prepare yourself for the Man of Black.